So what we discuss here, fluid pressure. Fluid pressure means what? Like pressure exerted on the fluid liquid. So what is pressure here? Force per area. So force exerted around that object normally by unit area. That is the fluid pressure. So this was given by Mr. Pascal's. So we have as Pascal's law. What it says, pressure in a fluid which is in equilibrium condition. So it will be same around all the direction. This will be same around all the direction. We are just neglecting gravity. So its application is hydraulic lift. Hydraulic lift, how does it work? One side thin, one side thick. Means more area, bigger area, chota area. Small a. This is bigger a. So small area, bigger area. So there we are applying a small pressure and more force is utilized. So overall pressure is same here. Overall pressure is same. Either we are using this one or this one. So they are bigger force by smaller, bigger area equals to smaller force by smaller area. So their pressures are same. In short, like pressure is what ratio between force and area. So same way hydraulic lift and hydraulic brakes work. So atmospheric pressure means pressure exerted around the atmosphere. That is atmospheric pressure. So at sea level, the value of atmospheric pressure is 101, is 1.01 into power 5. So exact value if you want, it's 101,325. 1, 2, 3, 4, 5. Yeah. Pascals or Newton meter square. Newton per meter square. So 101,325 pascals, exact values. Approximately 1.01 10 to the power 5 pascals or Newton per meter square. Hydrostatic means pressure exerted around the surface at the depth of height h. Next is your gauge pressure, which is sum of both pressures, like atmospheric pressure plus hydrostatic pressure, that is gauge pressure. Then next we saw buoyancy. Dipped inside the liquid, it will be how much it is going inside, it will be like same force it will be applying to push up. So this force will be equal. That is buoyant force. And this was given by Mr. Archimedes. So Archimedes principle, it says when a body is immersed, immersed in a fluid, it appears to lose a part of it, weight. And apparent loss of weight, which is equals to weight of fluid, is which is displaced away. That's what we have discussed till now. So today we'll start relative density and types of flow. That's what we are going to discuss today. So let's join. Everyone join, I guess. Yeah. Still some more to join. Okay. Next is your relative density. This is another important term after buoyancy. Now, relative density or specific gravity. They sometimes are using term as specific gravity. Whatever they use, meaning is same. So here we will consider all the liquid as incompressible. So liquid we will treat as a incompressible. So the density is constant throughout our discussion. So relative density is weight of substance in air divided by weight of similar volume or equal volume of water. That is relative density. Or other way we can say density of, or let's write this way. So this formula mostly I have used like relate this what we are going to write here, weight of substance in air divided by which is loss in weight in water. Or finally we can say here density wise. Density of substance by density of water at 4 degrees Celsius. These are three relation. Make a note of these three relation. In this one, see, whatever the things like that, we are just considering that density throughout that our consideration is like calculation or whatever observation. Density of that substance, it is not changing. We are keeping it as a fixed throughout. That is the first thing we are making it. Make a note of it. I guess it will take 2 more days, not tomorrow. I cannot finish by tomorrow because yeah, just okay. So as I said before, I will finish it by November. I don't think so. It will take one day more. Today is 29, maybe 30, 31. Because we're going to go for streamlined body, then Stokes law, and what else? At least one class for JEE questions. So 3 days it will take. 3, 4 days. Okay, done. If you're done, tell me. Any question here about this relative density or anything? Any doubt? Aditi, Meena, Sain, Akshit, Samhita, Tanesh. No? Okay. Then let's go for flow. Types of flow. Flow of fluids. This is very interesting. So first here, types of flow means how the fluid flow, like laminar flow, turbulent flow, and streamline flow, incompressible flow, compressible flow. So we are not going to discuss all everything that you will discuss. You will study those things in like your higher state of education. We'll study here like basic things what are required. So first one, streamline. Streamline motion. So have you heard of this streamline motion? Can anyone tell me what is streamline motion? No one? Are you guys there or not there?
Yes, sir.
What about this?
Yes, sir.
You guys are listening, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What about Samhita?
Yes, sir.
Okay. So streamline motion means like simple, like whenever the object like it's flowing, it will in simple words, it moves smoothly. So for understanding streamline motion, let me draw some different shape. Let's take this object. Can you guys hear me?
Yes, sir.
Okay, I got disconnected here. Okay. So for understanding streamline motion, I have drawn here three shapes. Okay. So let's draw here flow. A fluid will, yeah, fluid will flow here. Fluid in sense air here we will consider. I'm talking about air right now. Or water. It will go here. It will be moving here, and at this movement, it will drop. Same way here, it will drop here. Means this fluid, it will disconnect from the like object. So it will create a wake region. Wake region in the sense it will create a drag force. So it will create a drag force, it will move back here. Drag force is force which is opposing, friction force in the sense. In other words, friction force. Now, if I consider this object, it will be in contact here, 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 here. And again, it will be in discontact at this position. So here there is a small region. Here we got it as a big region here. Now, if we consider this streamlined body, this is streamlined body. It will be in contact here until it will be in contact till end here. So there will be a wake region only at little amount, very little amount, negligible amount. So this is the reason our aerofoil, airplane airfoils are like this shape. This is the reason for like that F1 car. They have, if you observe, they are made like this. And here person is sitting like this. If we sit like this, then there will be another drag region. He will create another aerofoil shape like this, and it will create a drag here, drag force. So he will not sit like this, he will sit aligned like this here. So his head will be intact. So these are the reason that is they are making a streamlined body. So that the flow which is there, it will not create a drag force. It will be intact with that object throughout the motion. So streamline motion, let's go back to our streamline motion. I hope you understand, everyone understood like what is streamlined body, right? This was whatever I was talking about, it was streamlined body. So everyone understood streamlined body? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
What about us? If
Yes,
no,
sir.
you can tell me, I'll explain again. Everyone understood? Streamlined object.
Yes, sir.
I drew 4 boxes. Yeah? Clear, everyone? Others? Akshit, Samhita?
Yes, sir. Clear.
Okay, super.
Sure.
So let's go with streamlined motion. Now, similar thing. I'm not going to change any words here. Same thing we are going to do. What I said just now. Similar way, we'll write some points so that we will remember for later. So here, let's say here, if fluid particles proceeding with some flow, and it is following some path here, some path it is following, okay, which is like a very smooth path, like without they will be in contact. So yeah, I got disconnected again. Power cut. Yeah. So I wrote already. So fluid flow, which is be in contact or intact throughout. So that is the streamlined motion. So streamlined flow. So the motion which is like either it is proceeding or succeeding the fluid particle which is following same path. That path is called streamline. Path is streamline. And the motion is called streamline motion. So we will consider here non-viscous. Which is having a very small speed, small movement. So don't get confused with the arrow marks. So what I wrote here in like short, I wrote everything. So streamlined flow means what? Fluid which is flowing and it will be in contact or intact throughout. In contact or intact. Now, if a fluid particle which is proceeding or succeeding the fluid flow, it will follow same path. That path is called streamlined path. And that motion is called streamlined motion. It will be flowing in with non-viscous fluid. It will be done in non-viscous fluid. That is what about streamlined body or streamlined motion. Principle of continuity. Okay, I don't know I can draw or not, but yeah. Some chota area and some bada area. So fluid. Now, this is too big, right? Now, if you observe, like airplane engine, so this is like gas intake here, and this is exhaust, nozzle and all that. Okay, in and exhaust. So exhaust side area is smaller if you have observed. So if I take here velocity of intake as V1 and velocity of exhaust as V2, area small, A2 is small, A1 is bigger, pressure here, P to Q. Now, whatever it is intake and whatever it is exhausted, sorry, yeah. So their mass will be equal. So M1 side should be equals to M2. This is what we're considering. So as we said before, it is non-viscous, incompressible, which is flowing in streamlined flow. So area and velocity we have. So V1, A1, rho 1, so delta time change, time will be equal. So V2, A2, rho 2, delta T. So what it says, from this equation we can understand that whatever mass is it is going in is equals to out. Mass is equal. Next, product of VA rho AV and for one side and rho AV for other side will be equal. So if you understand this way, if area is increasing, velocity decrease. If area decrease, velocity will be increasing. Likewise, like easy way to understand this one, like yeah, when you are watering with your pipe, okay. So if you want to go it far away, what you'll do, you will press the nozzle. So that flow of that water will be a far. So what you did, you decrease the area. Because of that, pressure is same from first to last. P to Q pressure is same. Okay, pressure from P point and Q point, it is same. So what will happen? For whatever amount it came, it should exit. So but now area has decreased, so it has to increase the speed. That is V2. V2 will increase. Here area decrease, V2 increase. Because density is same here for this condition, as I am talking about water and pipe. So density, if we consider same, because same water or same air is flowing throughout, so we can say V1A1 equals to V2A2. That is the equation of continuity. Any question here?
So the density is the same too, right?
Yeah, because same whatever fluid it is. Written? Okay, guys. Then let's see. See you on next class, that is tomorrow.